The Alps recall idyllic portraits of unspoiled nature, featuring peaks, glaciers, lakes and pastures. Yet, perhaps paradoxically, the Alps are also a surprisingly poignant reflection of the effects of climate change and the current conceptual, political and practical inability of our society to deal with them. Beyond melancholy, we can find refuge in the cold belly of pure science, systematically drilling cores in the deep ice before it's gone. In the strata, literally frozen in time, is a repository of the alpine microclimate, including human inhabitation's effects on it. An enormous amount of data stored in particles and molecules of air trapped in the layers of ice, every layer a year of history, a cycle of life. Decoding this data reveals a biocomputational alpine panorama composed of exponentially increasing carbon dioxide concentrations, unique diversity of contaminants and intense metabolic activity. Bioorganic growth reveals itself in the red coloration that can be observed with the remote eye of the satellite, as well as the unexpected nutritional qualities of the microalgal colonies proliferating within the melting crystals. A multitude of synthetic crystalliedrons which capture in living 3D printed microhabitats the unique complexity and beauty of this emerging alpine ecosystem.
The aim of the studio this year is to design a collection of synthetic landscapes for production. Each project will start from researching real-world case studies and specific process of production applicable to the alpine landscape. We will deploy advanced remote sensing and artificial intelligence technology to learn to see the way this industry current conceptualizes the living biosphere of alpine glaciers. We will then evolve our own protocol of artificial intelligence to manufacture novel 3D vision and artifact and finally install them in the physical landscape. To achieve this goal, the studio will engage the notion of synthetic landscape at multiple levels, as a design philosophy, as well as a collection of processes and systems, including human, animal, mineral, microbiological and digital. Our initial research will take us across the Alps and deep into the most radical current application of artificial intelligence and robotic automation to the transformation of the landscape. The studio projects will engage some of the pressing questions that are emerging from it, such as, for example, are automation and the advent of the Industry 4.0 engendering a sustainable redefinition of the spatial and material organization of productive landscapes? Can automation, as well as artificial intelligence, redefine the boundaries of work and leisure? And are fears of widespread unemployment due to automation justified? Is a new form of efficiency emerging within the artificial intelligence augmented productive landscape? The synthetic landscape projects will embody radical design scenarios where these questions are redefined and the related problem re-problematized. Synthetic landscape will make it possible for us to inhabit the realm of distributed systems rather than centralized ones, of trans-color systems rather than zone ones, and of heterogeneous cyborgian systems rather than technocentric ones.
The research module will take place in the first 3 weeks of the course and will investigate specific case studies of artificial intelligence applied to landscape transformation across the globe. Currently, 80% of all agricultural land is devoted to feeding more than 4 billion cattle, goats and ruminant livestock, and more than 2.5 billion chickens. Today, most of the herd's arable land is already being used for agriculture and livestock farming, covering over 1/3 of the entire land surface. To provide for the rising food demands, automation is now widely applied and a new kind of farming landscape is emerging. The studio will look at the transforming glacial landscapes of the Alps as a potential site for this emerging industry.
Methodologically, we will be working in teams of 4 students, including third year and fourth year students. Each team will research on a specific industrial application of artificial intelligence with a focus on a case study site. We will develop then high-resolution digital drawing of the case studies and its multiple systems. In this process, we will learn specific algorithmic design techniques. We will learn how to run machine learning algorithms to develop speculative architectural drawings. We will materialize our model with innovative 3D printing methods and embed them in the physical landscape. The design methodology was pioneered last year within the TerraFarm project, and we look forward to continue this curriculum this year in a collaborative format across multiple design studios.